Hello everyone. Today we are going to see the project name called AI-enabled Smart Energy Load Prediction System using LSTM. In today's world, electricity demand changes rapidly due to population growth, industrial activities, and unpredictable user behavior. Traditional forecasting methods like Riemann regression can't handle the non-linear and dynamic nature of real consumption data. Because of these limitations, there is a growing need for an intelligent and accurate forecasting system that can help power utilities, industries, and consumers manage energy more efficiently. For that, our project, we use long short-term memory, LSTM. This is a deep learning network to predict the next hour's electricity load. The system takes raw sensor data such as voltage, current, frequency, price, and past load values and convert it into a high-quality early time series dataset. We then apply feature engineering by adding time-based features like hour, day, month, weekday, and weekend indicators. A 24-hour sliding window approach is used where the model learns from the previous 24 hours to predict the next hour's load. This ability to learn long-term patterns makes LSTM highly suitable for energy forecasting. The trained model is developed through a Flask web application where users can log in, view prediction, compare actual with predicted graphs, analyze cost, identify peak hours, and get next hour forecast in real time. So now we will move on to our block diagram. So this is our block diagram. First, we are taking the raw data set and we are pre-processing the data set. Pre-processing means if any rows or columns has null values or duplicate values, any missing values means it will be cleaned. And then feature engineering and scaling. We are extracting features and scaling that features for giving our model. And then sequence generation, like we are taking 24 rows for predicting the next 1 hour. We are training our LSTM model for prediction purpose. At last, we are evaluating with RMSE and MAP. RMSE means raw mean square error and MAPE means map mean absolute percentage error. At last, we are integrating our backend to the Flask web application. In web application, we can see the visual analytics. So this is our training code. First, we are importing all the necessary libraries like Pandas, NumPy, Scala, TensorFlow, Job. And then here we are loading our dataset. Our dataset name is called dataset.csv. In our dataset, we have multiple columns, timestamp values also. We are calculating our timestamp into hour basis for prediction the next 1 hour. Like in our data set, we have our day, month, week, day, and weekend. So we are converting those columns into hour based for prediction. So what are the features we are taking? Means voltage, average current, and frequency, hour, day, month is weekend, weekday. And our target column is P underscore KWH, which is nothing but a load. We are predicting the load based on these features. So we are using min-max scala. Scalas means it will predict by accuracy. So we are converting our target column into scalars and our price column also into scalars. So here in our project, we are predicting based on the load, how much it is priced or like based on the features, how much it will be for next 1 hour load and how much price we can save. Like that we are going to predict. For that we are scaling our load scalar and price scaling. Here we are creating the sequences like 24 hours rows we are taking to predict the next 1 hour. Here we are splitting our data set for 80% for training and 20% for testing purpose. We are using LSTM sequential model. Sequential I used for means it has some layers. So each layers based on that layers it will predict accurately. At last with the 20 epochs and batch size of 32 we are training. At last, we are storing our model in the name of LSTM underscore energy underscore model dot h file. So this is our app code. So here we are integrating our backend to the front end by using Flask. So here we are creating our database. So our database name is called users and .db, like users, our database name. So we have some routers for the index page, index, about, contact, register, and login routers, and predicted route. So in the register route, you should have to give the name and email and password. Once if we give these details means it will store into our database. Once if you try to log in means it should ask email and password and then it will go into our database. If that email and password is already registered or stored means we will allow to predict or else it will show some error like invalid credentials. At last we have one logout page also. If you don't, so this is our prediction page. First we need to log in, loading our data set, and then what are all we did in the training part. Those things we are doing here also, like our day, month, weekday, weekend, these are all converted into our basis for predicting the next hour. And then we are loading our scalars, like scalar load and scalar price also we are loading here. And then here also we are creating the sequence. We are loading our model for prediction. And then we are defining like peak hours. 18 means like after 6 p.m. we are considering as a peak hours. So cost calculation here we are doing. This is for the plots. Like after running, we got two plots, actual load with predicted load and demand strategy. For that, we are creating plots here. So this plot should be like 14 into 6 size and it should have to show actual load and predicted load. For in the plot 2, it will show like actual load, predicted load and along with the price. So we are using sliding window. Why we are using sliding window means each time if you predict means that predicted 1 hour will be updated into our data set for continuous predictions. Like if once if you take 1 to 24 rows means next time it will take 2 to 25 rows, then 3 to 27 rows. Like that it will take and it will append our new prediction values into our data. At last it will return RNC, MAP, actual cost, predicted cost, how much we can save, and the next time load and our plots. It will show in our web page. So this is the command you need to give for run the code python space app.py. App is nothing but it is our file name. If we run means we got on link, we need to follow that link. So this is our web page. So A enable demand response in smart grid environment. First we should have to register and then login and then prediction. First, we'll register name, email address, and password we should have to give. After registration, we'll move on to the login page. Give me the same email and password which we have used for the registration. Once if we log in, it will redirect to our prediction page. So this is our prediction page. Energy load prediction result. Here we can see root mean square error, mean absolute percentage error, actual cost for it predicting like after 1 hour it should be like 125.63 paisa, but it's predicting like 134, so we can here we can't save anything. So next hour prediction it's telling and then load is 1.05 predicted load. So here we can see our plots. So this is actual with predicted load. So in the purple line it's actual load for next 1 hour and then predicted load is for 24 hours, and then based on the 24 hours predicting the next 1 hour, it should be in the orange color. So it is predicting peak. It is telling peak actual is 17.5 on the time, and then it's also predicting like near to that time only. So this is load with electricity price. So here it is also telling the actual load, predicted load, and price. It should be like how much price for next 1 hour. It's telling. So if you want to predict again means here we have a button predict again. If you click that predict again means it will predict for the next 24 hours. Like if it is take for now 1 to 24 hours means then it will take 2 to 26 hours, like 24 hours it will take. So it is changed our mean absolute percentage error and cost also. Now also we are not saving anything. It's predicting high cost only based on the 24 hours, and then load is like 0.99 load. So here also we can see the actual predicted load and then cars and strategy response like load with electricity price, how much it is. Back to home means we redirect to our web page. So here also once if you registered and log in means directly you can predict by using this prediction button. So this is our about page. In this about page, it has like what are all we done in the code. Those things will be displayed here like smart energy data preparation, advanced LSTM, load prediction, cost analysis, and auto forecasting. Those things we are doing.